So today we're going to be talking about parallel and perpendicular lines. Now the thing about parallel and perpendicular lines is they have very unique characteristics when with each other, and that's basically all we're going to talk about today is the characteristics between parallel lines and the characteristics between perpendicular lines. So when we consider the equation y equals 2x plus 5, these are equations that are parallel to our given equation at the top. Y equals 2x minus 7 is parallel. Y equals 2x plus 4 is parallel. And y equals 2x plus 8 is parallel. The equations over here are not parallel. Y equals 3x minus 8, y equals negative 2x plus 5, and y equals negative 1 over 2x plus 4. So these lines, these three lines here, we're going to determine whether or not these three are parallel to y equals 2x plus 5. So the first one, y equals 2x plus 3, is this parallel to y equals 2x plus 5? Well, yes, it is. The only reason it is because they share something very common. They share the exact same slope. So the rate of change between y equals 2x plus 5 and y equals 2x plus 3 is the exact same. So the slope is the same. Our next one here, y equals negative 2x minus 7. Well, is the slope, negative 2, the exact same as 2? No, it is not. So this is not parallel because the slope is different. The slope is different. And our third one, y equals 2x minus 7. Again, is the slope the exact same as up top here? Yes, it is. And for that very reason. Yes, because the slope is the same. So when we have these lines, y equals 2x plus 5, y equals 2x plus 3, and y equals 2x minus 7, and we go ahead and graph them, we're going to see visually what that looks like. So my first graph line here, y equals 2x plus 5. I'm starting off by stating my y-intercept, which would be at positive 5. And my slope or rate of change is 2 over 1. So I'm going positive 2 and then over 1 unit. Now the units on this grid, Cartesian plane, are all 1 units. So up 2 over 1 would look like this. 2 over 1. And if I was to draw a line, or go down to 1, it would look something like this. So my line, y equals 2x plus 5, is right here. My second line, y equals 2x plus 3, again, my y-intercept is positive 3, and my slope is the exact same, up 2 over 1, up 2 over 1, up 2 over 1. And I would follow this pattern, or follow this rate of change. So we have a blue line. It looks like this. So blue and orange are parallel. My third line that I'm going to be drawing, y equals 2x minus 7. So again, my y-intercept is negative 7. So I'm starting here. I know that that is a point along the line, but my slope is the same. 2 over 1, 2 over 1, 2 over 1. Passing through these 3 points, well, 4 points. Best that I can there. So we would have this line, which would have the exact same slope as the other two. The only difference is it is crossing the y axis at a different point. So in your own words, how can you describe an equation for a parallel line? Well, if the slope is the same, it's a parallel line. We know it's parallel. Something like that. If the slope is the same, we know that the line is parallel. So now if we consider the equation y equals 3 over 4x plus 4, we're going to try to figure out what does perpendicular mean. So again, we have on the left side here, all of these lines are perpendicular. So y equals negative 4 over 3 plus 4, y equals negative 4 over 3 plus 5, y equals negative 4 over 3 minus 2. These are not. So take a look at the slopes as we compare them to our initial equation here. Negative 3 over 4, 4 over 3, and 3 over 4. These three lines are not perpendicular, whereas these three are. So if we notice something about these slopes compared to the original line, we notice something. And we'll mention that a little bit later. But let's kind of go through and determine the same qualities of these lines. So y equals 3 over 4x plus 4. Are these lines perpendicular? Y equals negative 3 over 4x minus 2. Would that be the same as saying that line, or pardon me, is that line perpendicular? This line is not perpendicular because we're actually looking for something called the negative reciprocal. I'm just going to make a note here. Negative reciprocal. So you'll notice that the slope of this line is 3 over 4. The slope of these three lines is negative 4 over 3. So we took the slope, we took the rise and the run, and we just simply flipped them. So instead of 3 over 4, it's 4 over 3, and we took the negative, or the opposite value. So positive 3 over 4, the negative reciprocal is negative 4 over 3. So when I look at this line here, y equals negative 3 over 4x minus 2, is it perpendicular? No, because it is not a negative reciprocal. What about this line here? According to, or comparing it to y equals 3 over 4x, this is y equals negative 4 over 3. So is this line perpendicular? Yes. Why? Because slope is a negative reciprocal. And then our last one, y equals 4 over 3x plus 6. Is it perpendicular? No, it is not. It is not the negative reciprocal. So if I go ahead and graph these lines now, my first one I'm going to graph, y equals 3 over 4x plus 4. Y-intercept is positive 4. State that right there. The slope of this line is positive 3 over 4. So I go up 3 and then to the right 4. So up 3, 1, 2, 3, over 4, 1, 2, 3, 4. Now we get this point here. Now we continue that. 1, 2, 3, 1, 2, 3, 4. Now I have a line that goes through these 3 points like this. As best I can there. So that would be that line. The next one we have is y equals negative 4 over 3x plus 5. So my y-intercept is at positive 5. So my y-intercept here is at positive. Not a very good way to color this. just going to do this slightly different so we can see a little bit better. 5, and then I go -4 over 3. So I go down 4, and then over 3. Down 4, 1, 2, 3, 4, over 3, 1, 2, 3. So now I have a line like this. Passes through these 2 points. The last one I have is right here, y equals -4 over 3x minus 2. So I know I'm starting at -2 along my y-axis. And then the slope is -4 over 3. 1, 2, 3, 4. 1, 2, 3. Oop. 4. So then this line, go through these 3 points here. So the lines that we have just drawn on the grid here, these two are perpendicular to our first line here, and we can see that. So this line is perpendicular, this line is perpendicular. Or those two lines create a 90-degree angle, right? So again, takeaways for what we're looking for, in our own words, how can we write an equation for a perpendicular line? You can say something like a line with a slope that is the negative reciprocal of another, or something to that effect. So again, the big takeaways, when we have a perpendicular line, we have two lines with negative reciprocal slopes, and we've proved what that looks like. We have one slope given here, the negative reciprocals are stated there, and then any parallel line is a line that has the exact same slope as another line.